Okay, Journey, I'm going to go back through the 9.6 worksheet, one problem at a time, and I'm going to send those to you each individually on a video, so maybe you can kind of watch those again and see if they don't make more sense this time around. First of all, before we start, I want to just remind you, so we've been talking about the quadratic formula, right? A quadratic formula is just one of the ways that we can actually solve quadratic equations. Actually, we've learned three ways. We've learned that we can factor. We've learned that we can complete the square. And we've learned that we can use the quadratic formula. Any one of those three will help us to solve quadratic quadratic equations. So remember, we've been seeing quadratic equations that look more like this. I'm actually looking back, and you can do the same thing. On lesson 9.5 for the quiz, you're going to see problems that look like this. Y equals x squared plus 2x minus 8. We had another one on there that had a negative x squared term, plus 4x minus 5. And you can look back at lesson 9.5 quiz and see all the different, and the coursework too, and see all the different equations that we are looking at, quadratic equations. Okay, that's what these are, quadratic equations. And we've learned that quadratic equations, when they are graphed, they graph a parabola. Okay, we know that we can have a positive parabola, and we can have a negative parabola. The positive parabola obviously is shooting up toward the sky, whereas the negative parabola is shooting down toward the ground. And we learned that we can tell by looking at the equation which way the graph is going to go. We look at this term right here. If it is positive, then we know that it will be a positive graph. It will turn upward, and this one here is positive. If it is a negative term, as in the second equation there, it's going to have a negative graph turned downward. Okay, we also know that if we have, a graph that is positive, a parabola that's positive, the vertex is right here, and on the negative one, it would be right here. That is the vertex of the parabola, which means that's where it turns in the other direction, okay? And we know that if you have a positive graph, then your graph is going to have a minimum. And if you have a negative graph, your graph is going to have a maximum, okay? So just kind of throwing those few things out, let's see if we can jump into this first problem. I'm going to move it down here to the second page. Move that one up here for a minute. Okay, so let's go ahead and look at this. We have a bungee jumper who jumps from a platform. We're given this equation. This is a quadratic equation. What makes it quadratic is that it has this exponent of 2 on it. Okay, so we have the equation h equals negative 16t squared plus 200, and it gives the approximate height h in feet after t seconds, okay? So the way we've been seeing these written out would be like this. This is what you're familiar with. So this would be written y equals negative 16x squared plus 200. But because it's in a word problem now, they just changed the variables to represent whatever terms that we're talking about in the problem. So in this case, the h replaces the y, and the t is going to replace the x, or the t squared will replace the x squared. Okay, so that's what's happening here. So we're asked on letter A, what is the jumper's height after 1 second? Well, we know we're asking that for the height. So we can just take the original equation of h equals negative 16t squared plus 200, and we can plug in our values into the equation to find out the height. The height is what we're trying to find. So at the end of our problem is going to be h equals something, and it should be in feet, right? Because we're talking about, and I'm going to highlight in the problem here, the word feet. So we're looking for height in feet. That's what we're asked to find. when the jumper's height what it is after 1 second. Okay, so he jumps off the platform in 1 second. What is his height? So we're going to fill in the time for t. Time equals t, and it is 1 second. So we're just going to write that in here. So we have h equals -16. The time is 1 second squared plus 200. When you do the math on this, you're going to end up with a height of 184 feet. That's the answer to the first problem in your coursework. Let's look at the second one. What is the jumper's height after 3 seconds? All right, so we're going to do the same thing. We're going to use the same method where we know that the time is 3 seconds. Okay, and we're looking for the height again. What is the jumper's height after 3 seconds? So let's use the same. I'm going to write this out. Original equation here. And I don't know why I have two little equal signs there. All right, h, the height equals -16. And we're going to put a 3 in here this time because we're looking for what the height is after he jumps, after the 3 seconds of his jump time. So h is going to equal, we're going to end up with, if you do this right here in your calculator, you should get -144. And we add 200 to that, you're going to end up with 56. So when he jumps after 3 seconds, his height from the ground is going to be 56 feet. Okay, and in letter A, when he jumped from the platform, in 1 second, he was 184 feet off the ground. Okay, so that's how you do those problems there. I'm going to go ahead and end this video on this problem.